Hello, class. Because of the questions I've had surrounding the chain rule, also combining it with product rule and quotient rule, I have this video for you to discuss this extra practice, which covers chain rule, product rule, quotient rule. Well, and there's power rule here. But before I work these questions, I'm going to go back to the notes and calculate 6 derivatives. The first 3, I think of these as being directly chain rule. Okay, differentiate each function. No simplification is needed. How do I know this is chain rule here? Well, we see this parentheses with a function on the inside. And so I can see my inside function. It's 3 over x minus 2x over 7. And then my outside function is here. It's the minus 6 power. Maybe before I begin, we can rewrite this. You notice this is 3x to the minus 1. And then I have minus 2 over 7 times x. All of this to the minus 6. Now, I've not differentiated yet. That was just rewriting really the inside function to where I could see the powers. Now we calculate f prime of x. Okay, so derivative of the outside looks like this, power rule. Bring down the power to the power minus 1. And then we put in the entire inside function. We have 3 over x minus 2x over 7. You see, so far, I have derivative of the outside evaluated at the inside. Now, multiply by the derivative of the inside function. And I've already written each term as a power. So the first term, minus 3, x to the minus 2. And then the derivative of x is 1. So we differentiate here. We get minus 2 over 7. So here is f prime of x. This was chain rule. Next one, similarly, to calculate dq dt, chain rule. Here I can also rewrite, this is a cube root, so my power is 1/3. We have t to the 7 plus 5t to the 1/3 power. Now, dq dt, bring down the power, big parentheses, power minus 1. That's derivative of the outside. Now, put in the entire inside function. So derivative of the outside, evaluated at the inside, multiply by the derivative of the inside function, which, okay, we have 7t to the 6th power plus 5. Now, could you simplify? Well, if you wanted to, you could put this part in the denominator with a positive 2/3 power, but this is not needed. H of y. You see, could you do quotient rule? Sure you could. However, I have a constant in the numerator, and so it's simpler to rewrite my function as a power. I have y cubed plus 2y plus 1 to the minus 1 power. Once again, I've not yet differentiated. Now, h prime of y, bring down the power. We have y cubed plus 2y plus 1 to the power minus 1. Well, I usually color it something different. So what do I have so far? Derivative of the outside is here, evaluated at the inside. Now multiply by derivative of the inside function, 3y squared plus 2. Okay, now these 3, they are from the section 4.3 notes, and we will do 3 more from the section 4.3 notes before we move into the quiz 3 extra practice. Here we go. Well, same directions, differentiate, but here, fundamentally, I see parentheses, okay? So I'm going to do chain rule first, but then to take the derivative of the inside function, this will be quotient rule. It's not the only way we can do this, but this is the way I'm going to approach this question. So if I want dy dx, or you could write this as y prime, bring down the power, okay, power minus 1. There's the derivative of the outside. Now, put in the entire inside function. So 3x over 5x plus 3. Am I finished? Not yet. That was derivative of the outside. Evaluate it at the inside. Multiply by derivative of the inside function. So, denominator times derivative of the numerator minus the numerator times derivative of the denominator all over denominator squared. Here is dy dx. Okay, last two before we jump into the quiz extra practice. These are the ones that I was having questions on in class. And so in particular, I really wanted to put them in this video. So here, f is some unknown function. We want to differentiate each function below. Well, we really have to look at what it is here. So fundamentally, for the first one, you see, I have one function times another function. So the first thing I'm going to do is product rule. Okay, if I calculate dz, dx, we have first times. Well, now I need to differentiate what I have underlined in green. And here, okay, we have an inside function. To differentiate this, chain rule. Here we go. So we have the derivative of the outside. Evaluated at the inside times derivative of the inside function. So maybe I'll underline all of this is the derivative of what's in green. So now I have first derivative of the second plus the second times, well, the derivative of the first, derivative of x squared, is 2x. Okay, great. Last one, h of x is the square root of 2 plus the square root of f of x plus 1. Here we're going to have the chain rule more than one time. Well, the first thing to observe, every time we see a square root of something, the power is 1/2, and I'm going to be using that here. So the most outside function is a square root, and then all of this is my inside function. Okay, so we bring down the power minus 1, and then put in the entire inside function, which is 2 plus the square root f of x plus 1. Oh, make this black. Derivative of the outside. Evaluated at the inside. Well, now I need to multiply by the derivative of the inside function. Well, for the moment, what is my inside function? It is all of this. The derivative of 2 is 0, so I just have 1/2. Okay, maybe I'll color this also. I'm differentiating the square root f of x plus 1. You can make this gray. Derivative of the outside, evaluated at the inside, and one more times derivative of the inside function. Okay, fantastic. So all of these examples I just worked through are in our class notes, but it's a nice discussion before we move forward.